Good morning, afternoon, everybody, and welcome to the Arista PESA's live seminar titled Build Your IP Video Distribution System and Secure It Too. My name is Rob Shevlot. I'm the VP of U.S. Sales for the Central Region for PESA and your host for today's Arista PESA seminar. We thank you all for your interest and participation in today's seminar, and we ask all participants to please turn off your video feed, go on mute. Today, more than ever, there is an increased level of interest in the notion of security, specifically when it comes to video distribution networks. Today's seminar will focus on a modern generation of secure video distribution networks and highlight on how to think about and design the only end-to-end secure video IP distribution system. This will provide you peace of mind that your video audio data is safe and secure. The partnership between Arista and PESA solves these issues and will be presented today. Today's presenters will be Scott Barella, CTO from PESA, who will be presenting Secura, which will be followed by a brief demonstration by Johnny Jones, PESA technical support from our corporate headquarters in Huntsville, Alabama. Following Scott will be Robert Welch, technical solutions leads for Arista, followed by a presentation of the Arista EOS Cloud Vision solution conducted by Mitch, Vaughan, sales engineer for Arista. We'll end the seminar with a Q&A session, and we invite you to submit your questions at any time during the presentation in the dialogue chat box on your screen. And in the end, we'll try to get to as many as we can, again, at the conclusion of the presentation. Should we not get to your questions, someone from Arista or PESA will try to contact you via email to address and answer your questions. So, without any further ado, let's get started. I now turn it over to Scott Barella, CTO PESA. Scotty, take it away.
Thanks, Rob. Appreciate it. Hopefully everybody can hear me loud and clear, so I'll continue here to introduce you to our company, PESA. We're about 50 years old. We design and secure video distribution systems. These are used in command and control centers and VTCs for mission critical apps, but we also carry this technology into education and to corporate settings. And we also carry this technology, this video technology, into medical environments as well. We cover everything from sporting events to rocket launches. Our good friends at NASA use our equipment and have for the past few decades, and they know us to be very reliable, very robust, and above all, they see us as a very good, secure solution to their critical signals. Today, we're going to talk about our partnership, and as you all know, it takes two to tango. Robert Welch with Arista and I have formed a very good relationship and bond between our two companies. Today, we're going to talk a little bit about the end-to-end secure solutions that feature our Secura Media Manager and the Secura endpoints to connect end-to-end solutions for securing video and audio across IP infrastructures. And of course, if you're going to do that, you're going to need a network. And we couldn't think of any better network than Arista. And so what we are here to tell you about is a process where we can analyze the customer needs, design something, and then, of course, implement it with the help of our friends at Arista. Robert, go ahead and give us a little bit of background about Arista and how we got involved in media and entertainment and all the pieces and parts that make our partnership so viable.
Well, what's interesting about that, Scott, and thank you very much, and thank you everybody for joining the webinar today. And feel free, again, use the chat window as Rob said. This is a live webinar, so if we flub, you're going to see it live, which is a good thing. So, and we're going to have a little fun too. So, good. Bear with us as we do this. So, for those of you that don't know, Arista we've been around since 2008. We also do things with people who shoot off launches and healthcare and things like that. And so I really just say when people ask what do you do, we're pipes. We're like plumbing. We push packets around, but we make sure that there's no packet left behind. We're the guaranteed solution for networking, if you will. We're scalable, reliable, efficient, and programmable. And so that's where it all kinds of comes together, is once you have a platform, it's not just a switch, it's what you can do with the switch and the reliability of that switch itself. And to do any of these things that Scott just talked about, you need to have a reliable platform. Just think of like the tires that you have in your car. Hopefully, you have good tires on your car. Not everybody can afford great tires like run flats, but think like they're run flats and they're really good tires, and that's what you want to have. All right, Scott, back to you.
That's a good point. So together, it's a partnership that makes this work, because we're not necessarily the networking experts. We certainly know what we want to do with the network, but it takes a good partner to help us accomplish that. And so we developed really an end-to-end approach, something that we could provide to customers that not only had our endpoints and control software, but also the expertise of the networking piece to pull these signals together, push these signals, and connect these signals. And those are the kinds of issues that we saw as we started to head into this very new territory of IP video. We saw the need, as we're in right now, for sensitive and classified video and audio, but it doesn't necessarily have to be government sensitivity. It could be a patient sensitivity, or it could be just corporate sensitivity. But there are certain videos that you probably don't want circulating around the house as freely as other things might be. We also know that there's a need to change the settings, to reconfigure it and repurpose it for different needs on a day-to-day or a week-to-week or a month-to-month type basis. And that means the ability to support a number of different formats. This constantly changes, and I suspect before my days, Robert, that the 4K will be superseded by other formats and ideas and different color densities and makeups, and this seems to always change. And we have the need for real-time full motion video, and that kind of separates us from what others are doing. We like for today, we're doing Zoom video. This is a highly compressed video solution, because they're transporting this video information across the internet. And so there are different needs for that. In these other rooms where we're at, we think that real-time video is showing a huge need. And what I mean by that is it's no latency, right? Less than milliseconds of latency. That means low jitter and near perfect images. We also have situational awareness and transport awareness, more or less what Robert's going to show you with the EOS. This requires not only the situational awareness of a network, transport awareness. Comments?
No, you're absolutely right. I was just thinking to myself, as I think maybe not next week, but maybe next year, we'll probably be all wearing VR glasses or something like that, and Zoom will be all around us, right? And we'll have these three-dimensional things. But that's what the really the transport is allowing us to do. You think about doing something with SDI or one of those things. The IP is the enabler, and getting on board with IP is the first foray into it. And then the solutions you have are multifaceted. It's not just about video and what you can do with it. You were mentioning some of this before, is a healthcare aspect of it. The fact that you have to have real-time 4K delivery of that. Imagine if you were in the operating room and you didn't have all the detail, or you're a remote teleworker or something like that, and you didn't have all the detail to get that information out there. The details matter. And like you said, security, and we're going to touch upon this in just a little bit more, is security really, really matters these days. And everybody's kind of, I'd say, scared, but probably for a good reason, that data might leak. And so that brings us to our next thing, which is really, how do we solve that problem for customers?
Yeah, exactly. So, technologies and industries for us have been slow to adopt into the IP environments. And I think it's just because of the historical context of that. Broadcasters have used, for example, SDI. Other industries have used HDMI and DVI and certainly VGA historically. And these are all kind of technologies that existed either in some sort of a semi-digital manner, but they were done on matrices. And there's a growing need to move it toward IP because of the flexibility that IP brings to the table. That also bears out knowledge of using these networks. This is very new for video folks and the audio folks as well. But that's growing, and we see that as a good thing. But the thing that we see missing in this is the security. And so, while there are signals that we don't give a hang about with respect to security, there certainly other signals that of course do, and we want to keep those out of the hands of bad guys, right? We want to keep those out of the hands of somebody who is doing something a little bit more clandestine to our video, and we want to make sure we can take some of those pieces and parts out of the scheme so that whatever we're trying to present, we present securely. And that's really the whole notion behind a secure media distribution system. The idea is to encrypt this and so forth so that we can bring it from point A to point B securely without it exposing any of these bits to people that want to do bad things with it. I mean, so, and we see it all the time. We see it certainly in the data environments. We're going to see that into the video environments as well. So we're a little bit ahead of the curve, I think, in this. And, you know, this is why, you know, having a complete end-to-end solution with a partner like Arista is extremely important, because not only do we have these endpoints moving video from point A to point B, C, D, and E, and other points as well, we need to have a very secure network that can take those pieces and not lose any, drop any of those packets. The approach we took on this, and this brings us back to how Arista and PESA got together. It's actually because of people. Robert and I worked on one of the very first interoperability campaigns conducted by the Society of Motion Picture and Television Engineers, along with the Alliance for IP Media Solutions, which is AIMS. And together, Robert and I did the first demonstration of using IP, non-compressed video at the time, in the Arista booth back in 2016. So it was been some time ago that I was introduced to Arista, and it's been a good relationship. But that system is what you see in front of you. We have a flow of video in multicast for video. We have a flow of multicast for audio, and a unicast flow for bits and pieces of USB. And we're able to do that more like the scheme of the SMPTE standard. But what we bring into that is the yellow block, the idea of being able to take some of these flows and encrypt them at the very beginning, not the very end, but the very beginning, and move them around. So the concept is fairly straightforward, right? We take video from server assets or PC assets or even thin clients. The HDMI goes into our boxes where we take a little bit of the payload out and we encrypt that. We move that into the Arista fabric. Out of the Arista fabric, we come into the red block at the bottom where we actually decrypt it, and we bring it for display for somebody to see the video that they're supposed to be seeing. The idea is fairly straightforward. With the help of an Arista network, we can take various, I could fit more boxes on here, by the way, but for sake of argument, we just limited it to a handful here. But we've got a number of blue transmitters sending to red receivers. Now, one blue transmitter could send to all red receivers, for example, using the multicast that we have, provided that they have the decryption key for all the red receivers to see that. And it's really this ubiquity, this ability to traverse the network that's extremely important, because our payloads are fairly significant. And that's where, you know, where we're interested in making sure that these flows are protected and no, like Robert said, no pixels left behind. Bad pixels mean that we have incongruity in situational awareness, or we don't know what's going on, and that's a bad thing in the video side of things. The use cases are fairly straightforward. In the upper right, you'll see a place for video, or the virtual desktop environment or infrastructure, VDI. The bottom red boxes and blue box, or red boxes and black boxes indicate a kind of a class and unclass situation, for example, where you might have one unencrypted in black and encrypted in red. However you might decide that. This is kind of the use case behind it. But our boxes, our endpoints, are shown in yellow there with the Secura TX, where they go through Arista Fabric. And here they're using a traditional leaf spine architecture. They fan out to the green boxes and receiving, and we keep those groups together. So all the blacks are kind of together, all the reds are together. And not only do we handle, you know, PC and thin client type assets, we also carry pieces and parts of video and audio that are just strictly that, audio and video, and those can be traversed through the network. So the Secure Media Manager is really where the settings are done, right? So that we can dictate which of these boxes is a red or a black, for example, or a select group that you want to have secure, all the rest might be open. Any number of combinations thereof are conducive to that. Our intelligence folks like to use air gaps, and what they mean by that is that the networks are separated by air. They literally are not connected to one another, so that all the greens are together, all the reds are together, all the yellows are together. Reds don't talk to yellows and greens. Yellows don't talk to reds and greens, and greens don't talk to reds and yellows. So the idea is, even if there were encryption-based packets going across the network, they are all separate networks because they're separately used. Now, there's a combination, right? You can use a little bit of what I showed you earlier, and you can use this air gap. That's the beauty of Arista.
But hang on just a second there, Scott. I think you just actually mentioned a couple of things. I want to make sure that everybody understands this. You've got, if you can go back one, you've got choice. In this particular case, this is about governance, risk, and compliance and auditing. I mean, quite frankly, you want to make sure that it is secure. And how do you know it's secure? Because you're only plugging in these things, right? If you go back one other slide, this is what we call a zero trust model. You start off with nobody trusts anybody, which is, I guess, the norm these days. Or you want to have social distancing, sorry for the pun, between all the different devices. That's probably the only joke we'll get into today, or about that. But you start off with, you can't get access to anything by default. It's almost like a distributed firewall function, but until you're granted access, can you actually receive data? So you could put this reliably on a network that you currently have, or leverage what you currently have, and then through the certificate of authority that you have, the Secure Media Manager allows you. And then what's really cool about this, and we spent some time talking about this, is you could schedule this. It doesn't have to be an always on, always this talking to that. It could be on an as-needed basis, or I need to bring in somebody else as a second pair of eyes, right? Or somebody of authority to verify something or to look at something, like in a doctor's office, something like that. You can bring them in dynamically as well. So it's very, very flexible based upon your authorization that you're giving at a point in time. So you have both choices.
That's an excellent point. You know, the security can be only as limited as your imagination, really. We can really bolt these down, but as Robert said, there's a lot more to it inside the Secure Media Manager. But really, the overall concept is to be able to change things so that, you know, like he said, something on the bottom might change from a red to a black, or one of the guys from the red group needs to see stuff from the black group. That flexibility isn't taken into account for, as long as somebody of authority, like he said, has some handle on what that means.
Yeah, and I think Rob has a quick question from the team here. So Rob, hey Rob.
Yeah, the question was just posted, Scott, and I think that's appropriate right now. The question is there any delay with the encryption, de-encryption process?
That's a great question. You know, we thought about that from the very beginning. This went back about a year and a half ago. And we thought for sure we'd see some kind of latency in it. But because of the way that we use the compression, and it's not motion compression, that's one of the big pieces here. But the AES encryption that we're using is extremely low latent to begin with. So we did pick up but about 10 nanoseconds, which is a tenth of a millisecond. So yes, we did pick up some, but nothing like we thought we might. So from a use case perspective, we're really not seeing any kind of a penalty for the encryption in terms of latency. So the traditional matrix is kind of where we came from. Others have come from this at a different angle. Traditionally, we have used converters to convert HDMI to SDI. Others use HDMI straight up, but they are, in fact, core technologies that involve a baseband video in some fashion or flavor. In this case, we're going to pick on HDMI. But the point is, a traditional switching core has a frame limitation. For example, I have a number of inputs and a number of outputs that dictate the size of a traditional matrix core. For example, 100 by 100, very easy to understand. You have 100 inputs and 100 outputs. And when I get to the 101st input, I've got a decision to make. I either have to pull one of my 100 out, which is unlikely, or I have to get another whole nother switching core. I have to have one larger than the switch fabric that I have put together. In this case, it's silicon switch fabric. These were very traditional. This is kind of where we came from, right? This was our roots. And with it come a lot of limitations that we frankly have put up with because we didn't really have any other means to do this until now. When we changed the very nature of the video to IP, we have the flexibility of IP. And as you know, in typical business environments where, for example, you might have a number of PCs in the house that, I don't know, maybe you might have 100 PCs. And you get to the 101st PC in my example earlier, we simply add more switches. We add more connection, and that's where the Arista fabric is really, really strong. It's not only strong for that, but we couldn't ever do security in these traditional switch cores. Why? Because it just depends on consumer or professional type formats. In the case of SDI, it's a professional format, it's open. In HDMI, which is a consumer format, it's open. So no matter what you do, while it does accommodate the interoperability between devices, there is absolutely no security in that setting, right? So that's one of the key limitations to this idea of a traditional silicon matrix, whether it be HDMI or whether it be professional SDI. So we've identified a few things here. The scale is limited, the formats are limited. I didn't mention that you have to have a certain formats connected to one another. In other words, 1080p has to go to 1080p sources, 720p has to go to 720p sources, and if you have to have something in between, you either have to convert it or set the settings such that they can connect to one another. The security is extremely limited, and the agility and flexibility is limited. As you can see from the background of this photo, there are a lot of coax cables involved in a traditional matrix. We know we've installed a good number of them, anywhere from the International Broadcast Center for NBC all the way up to a number of key broadcasters and key operators throughout the United States and globally.
I think you're just trying to show off the cable art. Because the cable art
it is a work of art, though, you have to admit.
But what's funny is, and you see this in every room, every control room, you see that piece of paper up in the upper right, that's where you know things are plumbed. Or you try to look at that little tab, right? Whereas that's what your personality is. But in the new world, your personality is the device itself, the IP address, or whatever you're registering. And that means flexibility. It's not where you're plugged in. It's the fact that you exist.
Yeah. Yeah.
Hey, Rob.
Yeah, hey, Scotty, another question just popped up, which I think, again, is appropriate for where you're at right now. The question is, will you explain the method that is employed to decouple the video stream from the control system?
Yeah, so I'll save that question for this next slide. The decoupling occurs at the box, right? So that the HDMI, which is shown kind of where you see the server and the box, the tower case in this case, to the middle left boxes with S's on them. Those HDMIs are coupled to the box, and then the IP flows out of the box after it's been encrypted and moved through network fabric. And that vice versa happens at the other end, right? So we take from the IP scheme, we convert it back after we decrypt the video, and we give it to the monitor where we're going to control that. That happens also with the USB for mouse and keyboard, and also with other readers that have identification markings. The military and government use a certain way, another intelligence agency uses another, but they are kind of device couplings that are present at these workstations that need to be incorporated. But the idea here is that you could also use other types of video formats, for example, RGB, which is a very traditional 3-pin matrix, SDI, which has been used professionally, in this setting, where we convert that in the box named H to HDMI, and then we convert it to the input to Secura, and away we go. So those are kind of the brief couplings of these, but you can see quickly how the things scale, right? So that our control server at the top there are brought into the network under the black pieces for control, and then the actual essence flows are separated as red, and those are the encrypted flows that are happening. Now, they can be combined into the same network architecture. That's the beauty of IP. But everything from soup to nuts can be encrypted if that's the desire, or certain parts can be left open. It depends on the application, really, and that's where we had at the very beginning of the slide deck something about analyze, design, and implement. The analyzation comes in terms of the use case. What is the use case, and how could we use this technology? So when you break it down, you have a box that takes in the HDMI and USB simply. It goes into the Secura box's baseband signals, and then output-wise, we lock them down. Now, Arista doesn't really know whether they're encrypted or not encrypted. That's the beauty of this, right? So one of the key reasons why Arista is so fond of are so good at this is because they're already in these environments, right? They're already listed on the Department of Defense's Information Network approved products list. They're also on a number of other lists where government has been using their fabric for a number of years for reasons that we're using that. We can transport secure signals around a very secure environment, or we can augment that into environments where security hasn't been available. So, for example, in the medical industry, this hasn't really been something they can choose from off the shelf. They had to do some other crazy things to keep it all separated and so forth. Now, in terms of certification, and I'll get this in a little bit after the demo, but the certifications vary anywhere from the FIPS stuff to the Joint Interoperability Test Command, which is a part of the DODN piece. There's a whole bunch of acronyms and so forth that I won't bore you with, but they are the way the government wants to make sure that we're doing encryption properly. And that's really more the point of a certification. So with that, I will hand over the demonstration to
Brains. I want to know how Johnny Jones has got football up there. I'm kind of anxious to see what's going on.
Obviously, yeah, we'll have to see what he's got going on. But Johnny, good morning. I'm going to turn this over to you and let you demonstrate what we have and how this actually works. We're using our GUIs and the whole concept of connecting sources and destinations and the works there. So without further ado, here's Johnny Jones, a part of our service organization, and our engineer who's going to show you how this all works.
Good morning. Like Scott said, we've been doing this for 47 years. And we've gotten a lot of feedback. Just wanted to continue that tradition. So what I'm going to do is go ahead and show you what PESA has done so well for these 47 years with our control. And then we'll talk about how we're going to interface as we move forward with the Secura system. I'm going to share my screen with you. So here in my screen, you see our CatTrax software. We call it CatTrax because PESA's routers are all named after cats: cheetah, tiger, jaguar, etc. We thought it was fitting to call it CatTrax. What we see here is our matrix control screen. It's very simple. We're a destination-based router. So all we have to do is select a destination, and then we can go to our sources over here on the right. And by simply just clicking on a source, we can then hit the take button, and we've routed video. It's that simple. Customers love the ability to be able just to point and click and route their systems. Now that we understand that's how PESA works, that's what we've been doing so well for so long, now we're going to go ahead and talk about our new system. And our new system, the Secura system, relies on nodes. You saw in Scott's drawing there, he had these nodes placed on the sources before the network, and then on the other side connecting to monitors. This is our Secura transmitter or receiver. It's factory configured here at the factory. We have our HDMI connections. You have your network connections there. I'm looking at it backwards. And then on the front, the USB connections. Like I said, this could be a transmitter or receiver, depending on what you want it to be. I'm going to go back to sharing my screen. And we're going to go into our CatTrax IP software. Now this CatTrax IP software is our tool to be able to find all of these nodes that you plug into your system without you having to worry about it. So it's a plug and play system for you. So every one of these nodes are showing up here in our network capture where we catch under nodes. Now, we give you the ability to be able to name your nodes. Also, you can configure these systems to be static IPs if you want, but everything in this system is DHCP. And we can see the different flows here. We have the video, audio, and USB. In addition, we also have metadata. So once the software finds all of our nodes, we can then go to our map editor. And this is where we get to take that 47 years of experience and great control and be able to apply this new secure system. So over here on the right, we see all of the video flows, for example, and from those nodes, and then we can map those to our naming conventions for our configuration file. So here we've got names, workstations 1, 2, 3, and 4, and we've mapped nodes to those. And the same thing, I'm sorry, that was destinations. The same thing with sources, we can map those. Now once they're mapped, we can then control them just like we control a traditional SDI source on our traditional routers. So let's go back to CatTrax. And here in CatTrax now we can see that we've got those naming conventions showing up on our system controller, workstations 1, 2, 3, and 4. And it's just as simple as we've always done for the past 47 years. We just select our destination, and then we can click on our source. And now all of our video here, you can see at the bottom, has routed using the secure system.
Awesome. Thank you so much, John.
In addition to using the software, we also offer our touch panels or smart panels with relegible buttons and colors. And then we also have our touch panels, which allow us to control the system virtually anywhere. With that, Scott, I'll go ahead and hand it back to you.
Very good. Thanks so very much. We'll come back to some questions on that, but go ahead and stop your share, Johnny, and I'll put my slide deck back up. And very good. Go back to here. Pushing the wrong button doesn't help, right?
Hey, don't push people's buttons.
That's right. So what we are and what we're not, right? So we aren't MPEG. For example, today we're talking over Zoom, where you have a lot of compression going on. That's not what we are, right? So we push the bandwidth pretty hard. Why? Because we selected a JPEG 2000 codec that's extremely good at lossless performance and extremely low latent performance as well. So we can't be used necessarily for the Zoom type environment where we're used over the internet. We can be used for teleconferencing, but not in the sense of Zoom or WebEx or any of those kinds of things. So now, there we go. Some of the use cases that we see stretch, as I had suggested earlier, to both federal government, medical, educational, corporate, critical infrastructure, sporting venues. You know, what we're looking for is to help folks complete a very end-to-end solution. So much that we use these in our command and control environments for the military, and they look a little bit like this, where we take video signals out of a server room and we spread them around the room according to authority level. But we also do that in some medical implementations where, for example, an operating room might be viewed securely under HIPAA. And those are extremely important pieces because we don't want to lose the information that we're showing here to experts that need that information, but we also don't want to share this information because this is very private information. Imagine a sporting event, right, where you have a whole bunch of folks watching the scoreboard and somebody hijacks that video, like Mr. Max Headroom here. He's not so kind. He might say some things to the crowd here that you don't want him to say if you're the owner of this venue or the sponsor of this venue. So these are very real concerns. Not only could it be embarrassing, it could be damaging, right? We could create a situation that's not good. And that introduces the idea of being able to introduce security. Now, we're held to a little higher level. Now, it doesn't mean that everybody's going to need these certifications. It just means that some of our customers will use some of these certifications. So the Department of Defense has the approved product list, which I might add that we did the very first video distribution system some 7 years ago. We actually had to author, or help author Section 9. But this isn't always appropriate just to VDS IP. Arista has to go through the same sorts of things to get their APL listing, which they are right now. NIST, the National Institute of Standards and Technologies, has a crypto division where they actually test our cryptology and make us aware of the kind of threats that we'll typically see in very secure environments. So we have to undergo some testing on that called FIPS, the Federal Information Processing System, and they have some numbers that go with it. 140-02 is ours. So common criteria is also a part of this. We're not participating in that, but there are the three main criteria for certifications. Without further ado, and I'm going over a little bit, but I want to hand this over to Robert so that he can tell you about what we're doing going forward in the industry and how Arista is doing that with.
Yeah, so good question. So just staying on the topic of security, and that's a top of mind for everybody these days. Not only do you want to make sure you get your pixels there, get the packets there, but also make sure that while you're doing this, that you're not vulnerable to something like that. Now, there's a dirty little secret in the industry that every piece of software has some bugs. And it's really well known, but it's also well documented. So there is a place where you can go, a common vulnerability and exposure, a CVE location where there's a database. And every software vendor is required, as they find vulnerabilities, to go ahead and post these. And by the way, there are companies that go out there and they check for vulnerabilities. You hire them for penetration testing, things like that. So you really want to think about, from a vulnerability perspective, is where do we fit in this? And I'm not able to advance a slide, but if you can there, Scott. Thank you very much. Is this a bug or is it a feature? So you might get marketed, oh yeah, we've got a lot of features that we're working on. But from an Arista standpoint, we take this very, very, very seriously. In fact, if you look at our track record, and even go to our website, you can do that now if you want, or you can do that later. Go to arista.com and look at our vulnerabilities in there. Since I think 2008, if a number is about right, it's about 42 since 2008 of actual kind of vulnerabilities. And overall, this is where we actually pride ourselves, not only coming out with really good software that sits on the hardware to give you the solutions that you need, but also to make sure that it's secure, that you're not subjected to vulnerabilities. You're not doing upgrades to run from bugs or features. You're actually doing upgrades to get functionality to this. And so from a CISO perspective, from a security perspective, you want to keep an eye on this, is how secure is your infrastructure from a code perspective as well. And on the next slide, if we can go to that real quick. In order to do this, what we want to do is not just say that we can look at this in real time in terms of vulnerabilities and pass the packets, but we want to have a different operating system that allows you, or a different type of operating system, to do things with it. And then when the partnership with PESA, what we're doing is looking at the network as an analytics tool. You can now look in the network to see if the flows are running from point A to point B. So unlike an SDI environment where you plumb things in and maybe you want to have a confidence monitor coming out, how do you know how well, what's the DB loss on that particular piece of coax? Well, in this particular case, we're enabling all real-time information. All information in the network is being streamed. And so this is not just a promise. This is really a different way of thinking about, if you can go to the next slide, how you actually architect an analytics about the environment, about the PESA streams that are going on, and the overall health of the network. So in the old days, we used to do this thing called polling, and this is something that we did with SMP, Secure Network Monitoring Protocol. We basically say, hey, did something happen? Did something happen? Did something happen? And if something happened right in the middle, as you can see there in that second little loop, you're going to miss it. So you're going to miss these things. The other thing we did from a technology perspective is we said, hey, when something happened, let me tell the network. But what if you're not able to get that notification? What if that notification didn't make it all the way through to your system? Or you lost that notification somehow, your system didn't respond to it. Well, or if you want to know what was happening at 2 a.m. last night, how do I know what's happening not only from an interface up and down perspective, but was that because of a transceiver? Did somebody pull the cable? Did I get a loss of signal on that? So getting all that information, collecting information is power. So think about this: information, knowledge, wisdom. We want to get the information so you can make the right choices. Same like PESA, it's about situational awareness, to actually make real choices. And so for that, what we're going to do is we're going to give you an analog, but we're going to give you a demonstration as well. So think about like, and for those people who have over-the-top type streaming services, or you work with any type of video, lost packets mean buffering and all this other stuff. So we really want to think about telemetry information is not a loss of packet, not a loss of information, but true analytics real time. So the analog here is if you're losing information or you're losing packets, you want to know about that. And so with that, I'd actually like to turn this over so we can show you, as the proof is in the pudding here. And I'm going to turn it over to Mitch Vaughan. So Mitch, welcome. Oh, can't hear
Thank you,
you.
Rob. There we
you
go.
Yeah, mime. He's miming the whole thing. We're going to mime this thing. All right. And Mitch is going to show us something
Master
called
of the mute button. Awesome. Thanks,
Cloud
Rob.
Vision
All right.
Portal. So show us the coolness with cloud. And by the way, guys, we're going to touch the tip of the iceberg on this. Come back to us if you want to know more. We're just going to show you some of the cool things that we can do and not go into great detail about all the things, because that could be a 4-hour session. Mitch, up to you.
True story. Yes, it could. So thanks for handing it off, Rob. Can you guys see my screen okay?
Yep.
Awesome. All right. So this is the landing page of the Arista Cloud Vision portal. So you log in. This is ultimately what you're going to see. So as a network operator, I see all of my Arista switches listed here. We can free-form search on this. We can look for, say, I just want to see my core switches. I just want to see access. You can export the information to CSV on a bunch of different pages. But one of the things that Rob was touching on was the real-time information about the network. So a question came in that was around, hey, how do we do configuration of the Arista switches? Is it CLI? Is it a GUI? And the answer is really it could be both, and they are not mutually exclusive. So if we want to make configuration changes via the CLI, which we'll actually do here live, this is a production environment, a live environment we're using for a demo here. It doesn't mean that we can't use the GUI. We can also use APIs. So maybe we are leveraging Ansible. Maybe we're writing our own Python scripts. The point being is that we have that flexibility, and just because we choose one option, we're not locked out of any of the other options. So looking at some of the real-time data that comes off of these switches, again, it's not an SNMP polling mechanism where we're looking at it every minute, 2-minute, 5-minute intervals. This really is real-time, down to the second information. So I'll click on metrics here, and let's go ahead and back out of this and look at, for example, some dashboards that I've created in here that I look at as kind of my morning newspaper, right? So this environment, if I click on this, I jump in and I say, all right, well, how do things look? PoE, power over Ethernet, is running okay. The temperature of the switches looks good. It's just general information that I can take a look at and say, all right, cool, it's going to be a pretty good day. Or I look at it and say, all right, better make an extra cup of coffee because got some of my work cut out for me. Looking at the critical interfaces, what's connected, what's not. Just some information, bit rate in, bit rate out. It can be unicast or multicast specific in this case. And optics, right? So looking at the optics, we're talking layer 1 information here. I'm looking at the optical power for receive and transmit. Right now, they look great. But if those hop into like the neg 10, neg 12 dB territory, then you need to take a look at the optic or maybe take a look at the fiber that's running between them.
Now, hang on just a second here, because there's not a lot going on here. But
Sure.
If there were changes going on, this is a real-time screen, so things are happening. So this is not a snapshot. This is not a report. This is your view into what's going on in this particular environment. That's constantly being updated.
Correct. And actually, you know what? On that note, let's just jump into something that let's break stuff. It's more fun if we can break some stuff here to actually show things happening.
I like that.
So cloud tracers. Cloud tracers are a term that really refer to enabling a Arista switch, so any Ethernet switch running EOS, into a network probe. So it still performs its daily duties of, routing, switching, forwarding packets and frames accordingly. But also it can reach out to different destinations, whether they're external destinations or internal resources, and keep an eye on the jitter, the latency, and the loss to those destinations. If that destination can take an HTTP, a GET request, it can send a GET request and measure the response time of that as well. Now, as I'm going through all of this, it's worth noting that we can be alerted on this information. So if there's something that falls out of the normal range of latency, Cloud Vision can generate an alert and say, hey, you may want to take a look. The latency to AWS, so this environment here is how you can kind of look at the destinations and kind of guess what this is. This is a gaming lounge. So they heavily rely on Discord, Twitch. A lot of game developers, publishers have their servers in AWS. So we keep an eye on these destinations. If the latency falls out of a standard deviation, a normal range, it'll actually kick out an alert and say, hey, you should take a look at this. Likewise, if there's loss to a destination, it'll actually alert us on that as well. So let's actually jump in here and let's break something. It's more fun that way. So we'll go ahead and jump into switch core A. And we'll go in here and we'll actually break the network, the pings that are going out and measuring the jitter, the latency, and the loss to Google. Now you'll notice when we do this that the HTTP response time, that'll keep working because that's going to google.com, which doesn't resolve to the IP address we're going to use here. So we're just going to break reachability to that particular IP, which is just going to be Google's DNS server of 8888. So if we hop in here, we can do configuration in real time in EOS, so just like the good old-fashioned conf-t, whatever you want to call it. But we can also use something called a configuration session, which I am personally a big fan of because it saved my bacon quite a few times. For those out there that have operated networks, few things are more terrifying than when the cursor stops blinking. It's pure horror. So what's nice, though, is that if we have the ability to do this, this commit where we build a batch of configuration, for example, let's send the route to 8.8.8.8. Let's send it to the bit bucket. So we're just going to route it to null 0, which means that those packets are falling on the floor. They're not going anywhere. But instead of actually, notice that the cloud tracer is still reporting that things are good, even though we executed this command. So these config sessions let us build a batch of configuration to apply when we're ready. So what we can do here now is say, all right, cool, we have our full configuration built, which we can go ahead and do like a show session config diff, and it'll actually show us what is actually being modified as a part of this config session. But the point here is that we can actually now commit it when we're ready and then tie a timer to that commit. So you can see here that it's telling me in this section of the configuration, we're adding a route to null 0. Okay, cool. Let's go ahead and commit this. And we can just commit it outright and say go. Or again, we're going to put a timer on this. So let's do a timer, and let's say hours, minutes, seconds. Let's say for the 10-second period here, if we don't send the switch the all clear, which is just another commit, what will happen is the switch is going to say, hey, I didn't get the all clear from you. I'm going to roll this change back because something may have gone wrong. You may not be able to communicate with me anymore. And we can see here the cloud tracer in real time is detecting that something's wrong. And again, these are things that we can be alerted on, and this is an example of the information that comes in real time from the switches. So as a network operator, we can put these cloud tracers on our switches and probe different destinations, whether they're external, internal, as long as it is an IP reachable endpoint. And if it's a web server, we can send it GET requests as well. We can create one of these things. And notice that the change was rolled back. So there is history. So this is an example of some of the real-time data coming off the switches. But as Rob said, we're really scratching the surface here. If we go pick on a particular device, like say switch core B, for example, and we drop down here, there's a whole bunch of information we can get off of these devices. The multicast routing table, the IPv4 routing table, ARP, etc.
Topology information. I mean, there's just so much to it.
Yeah, actually, topology is a good place to, we'll go ahead and wrap up on topology. And for more information, anyone can reach out to the local account team anytime for a more robust demo. But we'll at least take a look at topology. And we'll kind of, let's go through a little whodunit scenario in real time. Let's see. Here we go. So this environment frequently hammers their network. They have a 1 gig up-down direct internet access link. And there's traffic going through here all the time. There's a gaming lounge streaming video, gaming, downloading files, updating stuff. It's nonstop. So the result of that is we have some fun information to play with. So I actually haven't troubleshot this yet. Let's go through this kind of whodunit scenario in real time. We can go here. We see that this link was hit pretty hard at this particular point in time when we click on the event. We can go to topology view. Topology view actually draws out how our switches are connected together. It uses LLDP to draw this topology view. Notice that not everything on this particular topology is an Arista switch. This is a little pfSense firewall. It just happens to be an LLDP neighbor.
And the PESA devices would show up as well. We just don't have them in the lab. In this particular.
There you go. Mm-hmm. Yep. So over here, it shows how they're connected, but we can also look at, are there any active events? Okay, well, it looks like at this point in time, there was an active event here on this guy. There was a warning. We click on that, and it's the throughput. Okay, well, what was going on? We can overlay information on these links, right? So now we're color coding the links based off throughput. So we can tell pretty quickly that whoever was slamming that link, they were sitting over here connected to switch access B, which is the PC arena in this case. Okay, well, now that we know that that's where it's coming from, let's actually take a look and see at this particular point in time, we can also get traffic flows. Who was hitting the link? And if we look at this, we can tell that, okay, well, there was one particular machine, actually a couple. It was 14 gigs of throughput. It was, at this point in time, it was 6 gigs of throughput just in data that it downloaded. It was quite a bit. So we can at least narrow it down to the exact endpoint that was transferring that data at a particular point in time. So we kind of went through a quick whodunit scenario there, troubleshooting as an operator pretty quickly. So with that, I think we're right up against 10 minutes here. Rob, I'll go ahead and turn it back to you.
Yeah, that's really good. Boy, I'm impressed, and there's a lot to it. And again, this is just touching the tip of the iceberg, man. So with that, Rob, welcome back. And also, Scott, why don't you come on back? So Rob, and also Sarah, any questions from the chat window?
Yeah, we got a few questions that have come up, some pretty good questions. We'll try to get to as many as we can in the 10 minutes. First question is how long does it take to make source and destination changes? I think that's probably more for you, Scott.
Yeah, so these are instantaneous. I think we've measured it in milliseconds, so we're talking about very, very quick switching. This is very, very similar to our traditional SDI switching technologies as well. So we don't see any degradation in terms of switch times. What does take some time from our endpoints is this business of the EDID communication going back and forth between the endpoint and the monitor that it is being connected to. For example, this is an advantage because if you're trying to connect a 1080p flow to a 4K monitor, the endpoint knows it's 4K, but it knows that the content isn't necessarily 4K. So we got a mismatch. And that's what's going on between the EDID device and the endpoint, so that the monitor says, hey, I'm 1080p. The device says, okay, I can give you 1080p if that's what your max limitation is. Here you go. By the same token, if I send a 4K stream over to a 4K monitor, they say, hey, I can take that stream, no problem. Don't do anything with it, just give it to me. So that process does take a few seconds, and I have no control over the EDID portion of that. But generally speaking, in the environments that we're accustomed to, these video sources stay up. But obviously, if you didn't have those pieces and parts to it, we could make that shorter, depending. This, again, it comes into the use case of what you want it to do.
Fantastic. Thanks, Scott. I think we might have one more question here. Let me see. Yeah, I think it's just it was just answered by Mitch on that, so I appreciate it. This is one, Scott. I think we covered this. If not, I apologize. Ask again. But the question was the method that is employed to decouple the video stream from the control system. I think that's one you might have already addressed or not. I honestly.
Yeah, I don't know if that's referring to the actual addressing scheme. So there is a source port where flows come in and out of, but the flows are designated by way of multicast address, which are assigned separately. So that's the decoupling, if you will. I'm not sure that really answers that question, but with respect to USB, those are typical TCP ports, right? So we connect them one at a time. We can't do the multicast trick on USB simply because you can't have dueling keyboards and dueling mice on stuff. So, the folks that we're working with prefer to have one-to-one setup so that when you do connect the USB, it's a one connection to one destination sort of thing. But that's all a part of that. While multicast is flowing within the network, we also have pieces and parts of the control system using, UDP, TCP, and FIPS encryption as a result of that. So those are all kind of held separately, but they don't interfere. I know I saw a little blurb on whether this is a non-blocking architecture. Yes, it was done that way because we designed it that way, and I think that's really more the point of this. But because of that, that's one of the million reasons why Arista is with us. They help us once we look at our design and go, look, we've got this many flows. They all are 1 gig a pop. Some of them may be a lot larger. We can't have any blocking on this. And they go, well, okay, then what we want to do is we want to do this and we want to do that, and we're gonna help do that part. So we don't have to be the experts in the network part of this, right? To supply a fully redundant and open non-blocked environment has the skill and backing of the fine folks at Arista.
We're going to try to squeeze in 2 more questions here before the time's up. Again, the question is the source with its encryption is changed, does the decrypt, et cetera, change to match? In other words, is there a matrix of crypts to choose from?
Yes, there is. These are fixed keys in our first version, but in the one that we're working on right now, they're dynamic, so that they can change during the operation, they can change as you wish, or they can stay fixed.
Okay.
These keys can be inserted by the operator, who can generate his own sets of keys so that they stay, guarded. We can certainly have some input in terms of what we think that should be. Now, this first version is albeit rather archaic, but the point is there isn't any other architecture out there that I've seen that enforces encryption throughout this, even though we're using just fixed keys. So, yeah, are we going to stay there? No. Are we developing it? Yes.
Okay, fantastic. I think we're going to try squeeze in one more here, again, because of the brevity of the answers here, and hopefully helpful. And this is, let me pull this up here. This is following up on the distance thread. Is handshaking necessary for control and or essence? And if so, what happens when connections are via satellite and inherent high latency?
Right. So whatever sources come into the SCIF, or whatever the satellite sources come in, are the baseband derivation of the decryption. So in other words, all the signals that come into a protected environment have already been sanitized and blessed, so to speak, to move around the closed facility. I'm not sure this quite answers your question, but there is no handshake back to forth. There's a control system that's monitoring who's connected to what. So we don't get like an RTSP thing where you're saying, hey, you're going too fast, or hey, you're going too slow when I need this and that. That was kind of the old stuff that we did before streaming really took off. So we're not using that kind of technology. We're using a very deterministic kind of a setup, so that we say, okay, here is the endpoint that's I want to send my information to. Here's the video source. I want to connect these two together. And oh, by the way, I want to put this on the monitor wall, so that these two sources are cleared for takeoff. They've been instructed to do such, and there is no handshaking. It's a dictatorial thing. The control system dictates what is connected, just like the routers are now.
Okay. Thank you, Scott. Hey, it looks like we're up against the time, and probably like everybody else, we'll all have back-to-back Zoom or Teams meetings, so we're probably all ready to log on to another one. But again, if we didn't get to your question, somebody's going to reach out to you, because we want to make sure we've answered your questions fully. Even the ones that we address, we'll probably reach out just to make sure we touched all the bases. But again, on behalf of Arista and PESA, we want to thank each of you for participating again in today's seminar. And we also want you to, for further information, check out our websites. And again, a bunch of information on our websites. And there's also a box there, drop down to contact PESA or Arista and have someone follow up with you. But again, on behalf of both of us, we want to thank all of you for participating. We hope it was helpful, but more informative. And again, thanks to everybody, and y'all have a great day.
Thanks all.